Hey there, year 11s. In example 19, this is a pretty fun example to do. It says quadratic function, and our quadratic function, that already tells me that f of x must be of the form ax squared plus bx plus c. So I need three unknowns. I got a, b, and c to figure out. You can do this by hand if you want, but it looks to me that they're telling me f of 4 is equal to f of negative 2, which equals to 0. Wow. So for those who don't understand this, you got to break it apart. It's saying when x equals 4, that's the same as when x equals negative 2, which is y value is 0. You see what they're saying there? Because if you break it apart, if they just wrote f of 4 equals 0, well, that just means when x equals 4, y equals 0. But they've done it in one nice succession, so that's why you know they're saying when x equals 4, y equals 0, and when x equals negative 2, y is equal to 0 as well. So they've just given you two coordinates. They said 4, 0, and negative 2, 0. Now that's a big hint. That tells me that the quadratic equation, you don't have to do ax squared plus bx plus c anymore, but you probably can now apply, since you know the x-intercept, that's the x-intercept. If you actually did a quick graph, 4, 0 is here and negative 2, 0 is over here. You've already got the intercepts, and it could be this graph or it could be this way. That's the thing that's special, right? So I already know the two x-intercepts. It has to be at 4. Now to get 4, this has to be x minus 4, so that when we use null factor law, it will give me x equals 4, and then the other one has to be x plus 2. The only thing I don't know is how much the dilation is and whether it's a smiley face or an inverted function, okay? So I've got my model, and the other thing they told us is that f of 0 equals 16, and essentially they're saying there when x equals 0, the y value is 16, and they just gave you the y-intercept. So on the graph, not only did they tell you when x is 4, you got an x-intercept, and when x is a negative 2, you got an x-intercept, but they also told you that your y-intercept is at 0, 16. So clearly, just looking at the shape of this graph, clearly it has to be an inversion, shouldn't it? That's how easy it is, but that means my a should be a negative eventually. Now, that's the point for you to sort of figure out, and that's why it's special to work with. Okay, I'm just going to quickly delete that and then just drew the graph. So I'm just going to sketch the graph. There we go. One nice continuous curve, and that's at 0, 16. So now I've got my graph, my visualization. How do I find a? Because a is what I need to figure out. This is my dilation factor. And so I know I can sub when x equals 0, y equals 16 in, because I've already used the 4 and I've used the 2, so I need to use the 16. So here we go. We're going to work it out. Sub 0, 16 in. So 16 is equal to a times 0 minus 4 and 0 plus 2. 16 equals a times negative 4 times 2 is negative 8. So divide both sides by negative 8. That gives me negative 2. So a equals to negative 2. And that makes sense. I told you it was meant to be negative because the graph is going to be inverted. So therefore f of x must then equal to negative 2 times x minus 4 times x plus 2. That's the only way to get the x-intercepts at 4 and negative 2, and that's the only way that it has to be a negative, and we found out the dilation factor is 2 for it to cross the y-axis at 0, 16. Okay, so that's really all you needed to know, but you can see the function notation can scare students off, and this goes back to determining equations. So back in chapter 3, where quadratics usually is, there is an exercise on determining equations, and this is essentially it, except they're using function notations. Okay?